As our climate warms, melting ice from Greenland and the Arctic is adding large amounts of fresh water to the North Atlantic. This influx makes surface waters lighter and less likely to mix into the deep ocean, disrupting convection. A shutdown of ocean convection could have serious consequences, harming marine ecosystems and fisheries, disrupting global ocean circulation, and drastically altering weather patterns and extremes, particularly over Western Europe. We still don't fully understand the oceanic and atmospheric mechanisms that control how much and how quickly fresh water from the cryosphere enters the Atlantic. The regions between the Greenland ice sheet, the sea ice and the ocean are complex, dynamic, and can change very rapidly, just within a few hours. This makes them very difficult to observe, to understand, and to represent in models. I'm Christine Gommenginger, and I work at the National Oceanography Centre, where I develop new ways to observe the ocean using remote sensing. I lead the AEROSTATS project, an ambitious initiative funded by the ARIA Forecasting Tipping Points programme. AEROSTAT aims to monitor fine-scale exchanges between the cryosphere, the ocean and the atmosphere using new airborne remote sensing systems. Working with our partners, Radarmetrics, Noveltis and Pixelytics, we are developing a completely new, low-cost radar system to capture high-resolution images of total surface currents and winds. The project aims to demonstrate year-round sustained monitoring of currents, winds, ocean color, sea surface temperature and salinity using sensors on novel airborne platforms like airships, high-altitude pseudo-satellites and drones. If successful, AEROSTATS will provide a cost-effective long-term monitoring system to help develop an early warning system for potential convection shutdowns in the North Atlantic.